So hi, I'm the founder of Ehcache. I've also got with me, do you want to stand up please, Ari? This is Ari Zilka. He's the CTO of Terracotta. So Ari and I both had the same crazy idea about the same time back in 2003 to actually create caches, and we've come together, which is pretty interesting. So we're going to take it'll be about an hour and a half. I've got a presentation. This presentation I'm going to do is basically pretty much recent news. It'll be about Ehcache and Terracotta, which only happened, September last year. We're going to jump into how you scale, how you take an app and scale it with Ehcache through Hibernate. We're then going to take a look at some performance results we did in January, which I found really interesting, between various versions that we've done, and then we'll also look at the near-term roadmap. And Ehcache 2.0 actually is being released to the repos on Friday this week, and then all the press will go out next Monday, sort of announcing it more widely, but it's a pretty big release, so I'm going to talk about that. And then after that, we can have some Q&A, and if we've got time and people are interested, I've also got a demo I can do on a new thing that we're building, which is a console for Ehcache. It's a web-based console, which the idea is to actually sort of pretty much everything I know about how you performance tune Ehcache, try to turn into a tool. So that's a work in progress, but we can show you that as well. All right, so about Ehcache. It was founded in 2003. It originally started actually as a set of patches to JCS, Apache JCS, and then Gavin, I posted to the Hibernate mailing list and said JCS is broken. It lasted for us in production for only 10 seconds, and so we had this painful patching process and had to roll back, and so we fixed a couple of bugs, and then Gavin. And then I gave like you usually do, I gave the patch back to the JCS guy, and then a couple of months went by and nothing happened, so I posted to the list. It was really early days for Hibernate, and people, there wasn't much of it in production. And so Gavin said, oh, this is terrible, and contacted me and said, can you create a new cache? And I'm like, well, not really, it's a huge amount of work, I don't really want to do that. I've solved the problem, we've moved on. And he said, oh, if you create it, I'll make it the default cache in Hibernate. I'm like, oh, okay, all right. So I thought, okay, well, I'll just fork it and just apply my patches. But when I looked at the code, and there was a lot of stuff I didn't need, I sort of looked at the code. Then in a space of a couple of weeks, I just like ripped it right back to bare metal, and I mean today there's nothing in common at all. But that was where it started. So it has an Apache 2 license, which suits most people. It's integrated with by lots of projects and products. You guys would be aware of that. Just some recent ones, Grails. There's a Grails guy right here at the front. So Grails actually switched over to Ehcache about a month or two ago. So pretty excited by that. Obviously Hibernate's used it for years. One thing we've just done is change up to use the latest SPI in Hibernate. It's basically used in lots of places, as you guys know. I won't labour that point. Just running through the history of it. The Hibernate provider was the starting point. I was working at a .com called whatif.com. The next thing we needed was web caching. So the page cache and page fragment cache have actually been in Ehcache, for 6 years now, and they're used in production by all the Whatif websites, which are they're the busiest websites in Australia, and by lots of other people as well. So that's another aspect of Ehcache that you may not know about. That's in the Ehcache-web module. It's all modular these days, so that the core download doesn't get too big. Distributed caching, which I guess eventually has led me to Terracotta, started down that track in 2006. There was a colleague from ThoughtWorks, Paul Hammett, and he'd been going around telling people it was a distributed cache, and I said, no, it's not a distributed cache. And so I thought I'd better make it one. So I added RMI distributed caching that you're probably familiar with. Also, since then, I've added on JGroups, which was a contrib, and then JMS that I wrote myself. Then later on, I became co-speculative JSR 107, which is Jcache. I then did an implementation of Jcache in 2007. The JSR has been, I think we're now officially the longest running JSR. It's been going for 10 years now. I've decided to sort of get going again with it, and Steve Harris, down the back there, is actually just joining the expert group. So if nobody else does anything, Steve and I'll do stuff and make it happen. Something interesting actually with that, has anybody here used Google App Engine or played with it? So so with their caching API, they actually found a library from somewhere for Java Ehcache, which is JSR 107, and they made that the interface. And it was sort of pretty crazy because none of us actually on the expert group know what's actually in that jar or what source code it corresponds with. And it certainly isn't the version that I wrote my implementation against in 2007. So in the latest version of Google App Engine, they've actually changed that interface. They're now using net.sf.jsr107 cache as their interface. Now I actually wrote that and put that up in SourceForge, and it's also up as a Maven module. Now that is what this Jcache module is actually written against. So there's a guy called Cedric Lime, who's a contributor with me to the Ehcache Google App Engine module, and the last couple of releases of Ehcache, it's worked in Google App Engine. It's not particularly useful because Google App Engine is limited to only 100 meg of heap, but what the Ehcache Google App Engine module is about is hooking up Ehcache as an L1 to Google's caching infrastructure as an L2, and you'll be able to plug it in through their net.sf.jsr107 cache. So we'll probably do some more on that in the next few months. It'd be nice to actually get that out. Nice thing is, if you write an app, then you can keep using Ehcache as you're familiar with, and then we handle the calls to and from Google's caching infrastructure, and you actually get the benefits of actually having an in-process cache. If later on they actually increase the amount of memory that's available in the L1, well, that would be nice too. But you can still very worthwhile having, say, 20 or 30 meg of cache available in the L1, and then the ability to actually overflow to the L2. The other thing is there's a thing called Cache Server, which is a standalone. It's either a WAR, or it actually comes bundled with Glassfish v3 now. I'm doing a new release hopefully this week, and that contains a resource-oriented RESTful implementation for caching. And since that was done in 2008, a lot of our competitors have actually taken the idea and have actually copied it. If you think about HTTP, the HTTP operations, they actually map very, very nicely to your cache operations that we have in Ehcache. So it's a really nice, elegant thing to do. That also has a SOAP API, and I'm doing a talk in New York on Thursday where we're going to actually run it up on EC2 with a giant Terracotta cluster with the cache server sitting in front, and actually everybody in the SIG will sit down and actually write clients in their language of choice. We'll actually see how it actually is working with Terracotta backing it. So there should be a new release of that coming out this week. Picked up SourceForge Project of the Month in 2009, and then acquired by Terracotta also in 2009. And so I work full-time for Terracotta these days, and it's amazing how you think you're going to have so much more time, but then your workload goes up as well. There's like a massive dev team at Terracotta who are like rapidly adding features to Ehcache. So it's amazing. I actually spend a lot of my time now architecting and designing APIs and discussing with the devs how things should work rather than actually coding it myself. But I went through a period of about 3 months where I didn't code at all actually, but I've actually picked up the IDE again in recent weeks. Now, shortly after, a couple of months after the Terracotta acquisition, we actually integrated with Terracotta Server Array, and I'll talk about that more through the talk. Terracotta, for those of you guys that don't know, it's a startup. The whole focus of the company is on application scale, very large caches, very large enterprises. It's commercial and open source, so I'll talk more about the product additions in a tick, but Ehcache DX and EX, there are open source. So Ehcache, obviously, as you know, is Apache 2. You can also, there's a thing called Ehcache DX, which is the same thing, but with support from Terracotta and the other things that come with that. I'll talk about that in a minute. There's also EX, which is Ehcache paired with Terracotta Server Array. That's also available open source or in the EX product. There's also FX, which is the big daddy of them all, which is Terracotta Server Array with striping. So you can go to very large caches, and that one is commercial only. Seems like a fair way to split things up. It's sort of similar to the old MySQL model. The monitor as well will be provided to people that buy one of the supported versions. So it's very similar once again to MySQL. You get MySQL Enterprise, which is a monitoring tool to use. So it seems like a nice add-on for people that want to buy support. Ehcache is pretty ubiquitous. Sun last year at Java 1, they said they did a survey of their customer user base, and they said they found that 70% of their customers were using Ehcache. So we think that's got to be at least 100,000 plus enterprise deployments. Terracotta's main offices are right here in this building, and also in New Delhi. And then there's sales and developers scattered around the world. I'm actually based out of Brisbane, Australia. We've got people in Europe. We've got people across the US. And where we don't have sales offices, we've got resellers. So I actually work with a guy in Australia. The key thing, and I'll show you tonight, is the scale continuum. It's the idea that you can start off with Ehcache, use it open source. You can use it open source forever. If you want the features that Terracotta can bring, and you want support, or you want the massive scale of striping, you can do it without disrupting your app, and that's the key thing. All right, here's the product. Here's the products once again. So we've got DX, EX, and FX. So it just goes up alphabetical order. DX is Ehcache as you know it, without Terracotta Server. EX is with the Terracotta server, and FX is striped. A recent focus for ARI, actually in particular, is the cloud, so focusing on EC2 and Eucalyptus. So we're actually building a tool for FX, which is which automates deployment to both EC2 and Eucalyptus. We've been playing with it today, right? Yep. There's the other thing, I don't know, probably a lot of you use Quartz as well. So Quartz joined the Terracotta stable also last year, and similar naming convention. You can use Quartz open source, or you can use it supported, or you can use it with the Terracotta server array in striped and non-striped versions. And we've also got sessions. There's been a big revamp of sessions, which is also coming out this Friday, which is a lot easier to use. And also Terracotta for Spring. So just what is in the commercial offering, I'm going to get this bit over and done with, and then we'll jump into the tech. You get 24/7 support, you get guaranteed time to respond, SLA, you get patches, so we've got patch lines. If you have a problem, we'll basically create a patch just for you. We've also got field engineers, so there's consulting available as well. We can get field engineers out to help you. Yeah, it's basically commercial open source. Right, so can I just have a show of hands? How many people use Hibernate in the audience? Okay. And how many people do caching, second level caching with Hibernate? So that's less than the people that are using Hibernate, is that right? There's people here that use Hibernate without using second level caching? Yeah? Is that right? Yeah. Okay. Actually, while we're on ORMs, something else I we did, about a year ago, we actually did OpenJPA 0.1. And Kevin Sutton from OpenJPA actually was supportive of that and actually looked at our code. And then we did, a few months ago, we actually did a 0.2 release, which will integrate with Terracotta. It's an improved release. So we're basically planning on supporting OpenJPA. It's obviously not as mature as Hibernate, but supporting that through time and building that up. How many people use OpenJPA or are interested in using OpenJPA? Right, okay. Yeah. The next idea I've got is Eclipse Link. So it seems to me we should be supporting Eclipse Link as well. So Sean Smith, who's the Eclipse Link maintainer, is based in Toronto. I'm actually sent him an email today to say that I'm interested in doing a Ehcache plugin for that. Who uses Eclipse Link or is interested in using Eclipse Link? We've got two people. Cool. All right. Well, I'm pretty keen on doing that. Yeah. All right. All right. So let's look at some code now. I never know how to judge these things. So this is at a more just basic introductory level to how you wire up an app that's using Hibernate to use second level caching. Spring Pet Clinic. Is everybody familiar with Spring Pet Clinic as an app? Yeah. So so we actually use Spring Pet Clinic. I'm using it in this example of how to wire up. So what you've got there's the domain model. You've got vets which can have specialities. So there's a many-to-many there. You've got pet owners who own one or more pets. A pet is of a pet type, and a pet has visits to the pet clinic. So I mean, this may be preaching to the converted, but then there's people here that don't use Hibernate. It's always hard to work out how to pick this, but you know, I myself have spent days tuning Hibernate to get every last ounce of performance out of it and tuning all the caches and so on. But you know, these are the starting points. So what we're going to do when you get Pet Clinic, when you download it from Spring, out of the box it uses JDBC. It doesn't use Hibernate, so we're going to configure it to use Hibernate, and then we'll configure Hibernate to use a second level cache, and we'll of course use our own cache. I'm going to talk about our caches because you actually have right now 3 choices. I'll talk about those choices. Then we're going to configure the mapping file for caching, and then I'm also going to look at the query code and actually show you. A lot of people sort of don't realise that the query caching mechanism in Hibernate is quite distinct and needs to be separately configured. And then a couple of optional steps. All right, so I'm going to go over to the IDE. So when you grab Pet Clinic, that line there that I'm on is the one that's actually uncommented, and so it uses JDBC. So to play around with this example, you need the application context -Hibernate. So it's just a matter of, it comes with this line and it just uncomment that line. And then we go over to that application context, and then that line there, Hibernate cache use second level cache, that's where you turn on second level caching. And when now Ehcache used to be the default, and then I think something irritated them about the singleton versus non-singleton when they were trying to get JPA going. So then they made just a hash map, which they don't recommend for production, the default. But Ehcache is still in the config file at the top of the list, so almost the default. Right, so I mentioned before that you've got 3 choices. So you basically have to choose a caching provider. Now, let's go back through history. So Ehcache since 2003 has been a caching provider. Now, you've got, when you download Hibernate, obviously you get Ehcache with Hibernate. And Gavin King has been a committer to Ehcache going way back. He hasn't done that much, but he's actually looked after this caching provider area. So you've always been able to actually use the cache provider from out of Ehcache, which is in the net.sf.ehcache package, or out of Hibernate. And we've tried to keep the code in sync. Now, what I'd recommend to you is that if you're not using the Ehcache that comes in Hibernate, like let's say you're updating Ehcache, then use our provider, use the provider that comes with Ehcache, because it's designed to work with that version. And it, I go out of my way to maintain backward compatibility, but then if you want new features, then you'll get it in the new version. So, Ehcache originally was singleton only. So it was cache manager.get instance, and then, of course, that irritated the dependency injection people. So then we actually created the ability to have new instances, which actually worked out quite well, because you can have multiple cache managers. The way Ehcache works is you've got a cache manager, which is a container for your caches. It has a life cycle. You start and stop it. When you start it, it looks for the ehcache.xml. It'll grab any caches that are configured there and actually create them ready to go. You can also dynamically add caches. Now, so you can have multiple of those, and I've certainly had configs where we've got apps with 2 versions of Hibernate handling different areas of persistence, like literally different versions. You've got a giant app that you're maintaining, and you just cannot upgrade Hibernate for that part. So you want to be able to run 2, and so that's a great example of where you'd want to. And that's why with the providers you'll see singleton Ehcache provider. So singleton Ehcache provider means it's a singleton, and then there's the other one which is just called Ehcache provider for the non-singleton case. At least I think that's what it's called. Now the other thing that happened, Terracotta wanted to provide a Hibernate provider for their own customers, because it's a very common use case, clustered caching in front of the database. And so starting around the middle of last year, they actually created a Terracotta Hibernate provider. Now that one, then that got released shortly, or about the same time as the acquisition of Ehcache, and so then we had 2. Now that one, if you're using Terracotta 3 or 3.1, and you need to use it with Terracotta server array, that's the one that you should use. That's this one here. Now both of those 2, both the Ehcache ones in the 1 dot range and the Terracotta one, used the service, the SPI in Hibernate's so-called 3.2 and lower service provider interface, and that was the cache provider. Now in Hibernate 3.3, what they did is they actually completely re-engineered the way the caching providers worked, and they actually deprecated the provider. So if you actually have a look at 3.3 or higher, you'll see that this stuff's deprecated. So what we've done in Ehcache 2.0, which comes out, it's been in beta for the last month, but it comes out on Friday, and if you want to get your hands on it before then, you can go and actually grab the beta. It's the same stuff, but less bug fixes, of course. Then this is what the new one looks like. So in Hibernate 3.3 and above, you've got Hibernate Cache Region Factory. So that's how you specify it. So we've actually updated the documentation on ehcache.org to reflect this if you're using that. Now in Hibernate 3.5, they also changed the SPI, just tweaked it slightly again, and that was only done about 3 weeks ago. And so so our gear actually takes advantage of all those changes from 3.3 through to 3.5. Now it's really interesting, I find it interesting. Hibernate up to 3.3 heavily used synchronized on its way to the cache. So now Ehcache did as well, so it wasn't that big of a problem. But when you get enough threads hammering away, synchronized becomes a huge problem. Now when Terracotta, who are no strangers to class rewriting and manipulation, what they did when they did their implementation is they actually took the Hibernate classes and actually rewrote them to actually rip out synchronized at runtime, so they could actually get really impressive performance numbers. And what was really fun and interesting was when we sat down with the 3.3 API, the Hibernate guys actually pulled all that synchronized right out. So it just flows through the cache. And of course, Ehcache 1.6 and higher pulled out synchronized as well. So you can, like roughly speaking, like if you've got, like the test that I write, that actually where I get my numbers from, if you've got about 100 threads, mostly doing reads, some write, some remove, some iterate over key sets, that's the benchmark I've been using internally for like the last 6 years. The Ehcache 1.6 on gets was 50 times faster than Ehcache 1.5. Now, it wouldn't have made any difference, and it won't make any difference if you're using that with Hibernate 3.2 or lower. But if you're using Hibernate 3.3 or higher, and you use our new plugin that's in Ehcache 2.0, you may see some pretty exciting performance differences. There's only one sadness in all this, which is that the query cache, Hibernate's query cache, still uses synchronized. So it's still a potential bottleneck. Right. And as I say, if you want to explore this, you go to the Hibernate page on ehcache.org. We've got all this laid out for you. The other thing is, I am actually committed to Hibernate project, and so I will be rolling our new gear into Hibernate, but I think 3.5 is imminent, so it probably won't make 3.5. So if you want to use this goodness in the meantime, get it from us, but we will be adding it into the Hibernate project probably in a month or two. Okay, so the next thing was mapping files. So what you need to do is you need to add this little declaration right here, cache usage, and whether you want read-only, non-strict read-write, read-write. Interestingly, in old Ehcache, which I'm calling any version other than the one that we're releasing on Friday, it wasn't, I didn't actually do any of the locking that was required for clustering, which is why on the Hibernate page it was actually showing that we never had the tick box for that. In practice, it didn't bother many people anyway, because people would just, they'd use it anyway. If it was something transactional, they'd do a session.refresh in the other node before using it. With the new implementation that we've done, if you're using it with, so we've only implemented this so far for the Terracotta backend, but the clustering we actually honour all of the clustering requirements in the provider. So we expect to be getting that tick for the Terracotta mode up on the Hibernate documentation as well. So you can safely use all of these modes distributed backed by Terracotta. If you're using RMI or JGroups or JMS, all obviously still works, but you just don't have that. You don't have the correctness. We're not doing the locking, so you don't have the correctness. It means that the two nodes can change things at the same time, and there can be collisions and so on. So you just add read-write to each one of these entities. I'm not going to get into collections. You also need to add a cache directive on your collections if you want the collections to be cached, obviously, as well. And then that will start caching these domain objects. Now, if you remember one thing, and only one thing from what I say tonight, the way that I do it, the way that I've always done it, it might be a bit bare metal, but what I do, actually not that one right there. I've spent days, as I say, tuning these things. What I do is I always sit down, I always take it, even like, let's say before you've even turned caching on, before you even touch it, right, just do show SQL and go and exercise some piece of user functionality of the app. Now, it doesn't matter what it is. If it's a web app, I actually always start at the home page, Start at the home page. If that's too complicated, I'll just get some smaller segment of that and then hit it. The Grails guy, if you're using Grails, this is wired in, it's exactly the same process. Turn on show SQL. You'll be amazed at how much stuff sprays across the screen, right? That's all database work. So yeah, it's scary. It's as slow as hell, right? So what you do is what your mission is to sensibly if you can, pull that down and lower that down. I mean, if you want to, the other thing you can do, even on a dev box, is write a JUnit test or something and actually just look at what the time is. Run it 10 times and see what the time is, and it's going to be pretty quick because you'll be using a dedicated database and everything. But the reason for doing it is that you can actually then get the comparative time. So you can look at what's going on with show SQL. You can also get your comparative time, and then you go and turn these things on. And because you've got a few moving parts, you've got to turn on Hibernate properties, and then you've got to turn on. Well, if you're using JPA, it's annotations, or you've got the Hibernate mapping file. You're doing it there. There's lots of little things that can go wrong. We, by the way, I'm planning on doing like a massive makeover of the Hibernate page on Ehcache. It was always, when I wrote it originally 6 years ago, it was like the absolute best reference for how to do this. And then, over time, there's like blog entries and everything else. We're actually going to do a major push and actually get basically everything that we know into one place. So expect that over the next few weeks to a month as well. But you work through it, you look at your show SQL, and then you start getting them down. So you want to cache your entities. Then the other thing that you want to cache is your collections, and then the other thing that you may or may not want to cache is your queries. So when you cache a query, if the query is the same, so the query cache holds the IDs of the result set from that query, and then if you've got a query that's cached, Hibernate will check that the query is cached. If it has a hit, it'll say, oh, okay, I want to grab these IDs, and then it'll actually go and load those. And if those domain objects are cached and the collections are cached, you can go through without hitting the database at all. So there's those three elements. There's the query, there's the entities, and there's also the collections between the entities. The other thing is that I've often found that in performance tuning Hibernate, you really want to look at changing your domain model and the relationships. It's like when you denormalize a database. Sometimes it looks really trick having all these collections every which way, but you can end up doing some absolute crazy stuff, which you'll see when you turn on show SQL. Now I'm just going to jump into Hibernate Clinic, and I'm going to show you the sort of things that you need to do with a query to turn it on. So here's a query right here. So this creates this query. Now this is basically everything in the vet table. And to make it cacheable, what you do is you actually just call on the query. It's got a set cacheable true, and that will actually, you need that turned on. The other thing that you need turned on is over here. You know how I said before that query caching and entity caching are like quite different and configured completely differently in Hibernate? Well, that's this one here. You've got to turn on the query cache. You've got to turn that on to true as well. I mean, there's so many times that people try to get this stuff going and it won't work. And it's not, it's just, Hibernate's slightly complicated about what you've got to do to make it work. Now, the other thing that you can do in Hibernate, for both query caches and for entities, you'd know this from using Ehcache, we've got a default cache, and so you can just create them. And I think you've probably seen these. Everybody's seen the warning that I emit saying that you haven't, we created it, but you haven't actually configured it. It's a really, really bad idea to use the default. It's great at dev time, it gets you going. Gavin King actually insisted on that feature. That one was from Gavin. But, in production, you've got to think carefully about the configuration of those caches, and once you get into distributed caching, it's very important. So default caches there is the developer convenience. I don't recommend them for production, which is why I stubbornly keep emitting warning messages at you. And I guess the Grails community's now joining in that as well. Now I'm going to flick back to the presentation. I'm going to show you these last two optional steps, which is so Ehcache ships with a default called ehcache-filesafe.xml. which is in the Ehcache jar, and that's got the default cache, and that's so that you can get up and running quickly. But you need to create your own ehcache.xml and stick it at the top level of your class path, and that's the one that you should modify. Now, for people that are using, actually, can I have a show of hands? Who doesn't use Maven? Okay, so about 10. Who does use Maven? Right. So not everybody put up their hands, which is why I did it both ways. But it looks like the Maven people outnumber the non-Maven people 2 to 1, is what I just got out of that. So if you're a Maven user, so if you download your stuff, you download a kit, and it includes an example, Ehcache.xml, with a huge number of properties in it. And there was a guy I was working with at What If last year, and he actually just sat down with a blank file and started creating one, and then was like complaining that, you know, I wasn't sort of giving meaningful error message for every single possible error he could make writing a config file from scratch. In response to that, Ehcache.xml has actually been put up on ehcache.org. So just go to ehcache.org. Right there on the left, there's a Ehcache.xml. You just click on it and you can actually grab it. And I suggest you start with that full file, which has got all of the config commented out for all the distributed caching, cache event listeners, all the richness that we have in Ehcache. Now, armed with one of those files, what a really simple example looks like is this. So you've got the default cache, which will be used to create caches if you don't specify one. In using Hibernate, so you'd create a cache which is the fully qualified name of the domain, and also you'd create one for the query cache. That's how you'd get rid of those warnings and also be doing something sensible. Now, there's 2 caches that Hibernate creates automatically, and so I've put these in here to actually show you what the correct names for those should be. But there's the update timestamps cache, and it uses that to check when a table in a database was last updated. And there's also the standard query cache, and which is where it actually holds the where it will cache your queries where you don't give it a name. And you know, once again, you generally want to control what the time to live is, how many elements you put in memory, and so on. Right. So I guess the way we'll do this is we'll have questions at the end, but I'm now going to leave or put down the Hibernate quick start, and now just going to move on to like part 2 of the agenda, which is actually talking about some of the perf numbers that we've got. Before I do, one of the funny stories is that Manik Satani at JBoss created this testing tool, and which used about 100 threads and this type of thing, and actually Ehcache 1.5, which was using synchronized, I suppose the test almost sort of showed up, was like a scenario that actually showed up the the effect of synchronized. And then so he asked me if I was interested in contributing to it, and I said, oh yeah, I'll take a look at it. So I grabbed it, and then I was working on 1.6, and so then by the time I actually sort of finished contributing to the tool, Ehcache 1.6 was then blazingly faster than JBoss cache or any of the other caches that he was testing standalone. So there's a difference. The numbers I'm going to talk about today are not the standalone numbers. The standalone cache, so when you're using Ehcache standalone, as I say, we've got a great story now for very large systems with multiple processors. We're using CAS, we've gotten rid of synchronized, and the throughput on the cache is really great. As I said, it's about 50 times faster for gets and about 10 times faster than puts over 1.5. And now that Hibernate's been fixed up, it will be interesting to see what can happen. Now, these numbers are all about distributed caching. Now, this what we actually tested was Spring Pet Store again. Now it's been done. The results I'm going to show you, we did these in January, and so they're done with 25,000 and 125,000 owners. And thinking back to that domain model, what that results in is in terms of total objects across all the domains is 0.3, so 300,000 and 1.5 million. The cluster config, we got eight machines in the cluster. There's 8 client machines. The Terracotta tests were done with 1 Terracotta server with a 6 gig heap, and then MySQL. Now Ehcache with RMI does pretty well on distributed caching tests. We haven't included it here because we're actually comparing, these test results are comparing Ehcache with Oracle coherence, running, and so it's basically a coherence versus coherence, and there's a cost to doing that. So that's an apples to apples. We're also actually showing Memcache D, which is not coherent. Obviously, is not coherent, but it's interesting that it's not particularly fast. So we're showing that one as well. We've got 15 threads. The IMDG is Oracle coherence. I'm allowed to say that, aren't I, verbally?
Sure. You already have.
Somebody told me I was allowed to say that it was Oracle coherence. They generally don't like you talking about perf for some reason. And then, yeah, Memcache, you've got 15 threads, you've got one server. So these are all pretty much one server for Terracotta and Memcache. And then we got coherence in near far mode. Oh no, replicated. No, near far, yeah, partition mode. We tried testing with replicated, but not all the tests passed, so we're just showing the partitioned. Now this is all done with Hibernate. Now, this is actually done with the Terracotta Hibernate provider. We didn't have the new Ehcache one done. The new Ehcache one, we think, is going to be about the same as this. But what's interesting is that these are for Ehcache 1.7 and 1.8, not for Ehcache 2 with the unified provider. But one thing that's quite interesting is that Ehcache 1.7 was where the original Terracotta integration was done, and then 1.8 was like V2, and pretty stunning performance difference. So 1.7 is the red line down the bottom, and then the green line is 1.8, and then the blue line is 1.8, but instead of using 15 threads, using 100 threads, and that was just to demonstrate that adding more threads, you can continue to get more performance. And then now the blue line down the bottom is the database. Now, you wouldn't be here if you thought that all you needed for performance was the database. So I think everybody in the audience already knows that you need some type of cache strategy to actually give you the performance you need. So the database, that's MySQL on its own, and then we've got Memcache, and we've got coherence just below Memcache. That's on the read-only. Now, just for comparison, if you've got a standalone cache, on that 100 thread test to me I think is a pretty good example of what a lot of people see in production. The Ehcache get speed standalone is 7 microseconds. So it's a lot, it's a lot faster than these distributed use cases. But distributed caching is all about scale and availability. In some ways, standalone caching, standalone in-process caching is an easy problem. This is more directed to the hard problem. Read-write. This is the read-write numbers. So the red line is MySQL. The orangey line above that is Ehcache 1.7. Then 1.8 is the green line at the top, and then we've got yellow line is coherence, and then we've got Memcache. Latency, so not just how many transactions you do, but how long each operation takes. Database is the highest. Then you've got Memcache. We haven't tested this, but I was looking into this a couple of years ago with Memcache. On the forums, you can run MySQL with what's called in-memory tables, and I don't know if it's still true, but it was true about 2 years ago that MySQL used with a JDBC driver with in-memory tables was actually faster than Memcache. And so there was a big fight, a flame war on the Memcache thread, which will still be there. And it had about 40 posts back and forth, but that can't be right, But basically, I mean, we don't show it, but some people do actually use do an in-memory cache using MySQL with in-memory tables. With MySQL in-memory tables, when you restart the database, all the data's gone from the table. So it really is MySQL used as a cache. And you should get pretty similar performance there to what we're showing for Memcache. Then you've got coherence, which is about the same as Memcache, and then you've got the pink is 1.7, and then the green is 1.8. Now, these performance numbers don't happen accidentally. You know, the team that, well, this testing is actually used internally to tell us whether the software is good or not, and so there's a huge amount of engineering effort has been put into improving the numbers that you see here between the versions, and it's really an ongoing thing that never stops. They're always trying to get better performance. Before we move off this, something else interesting that we're doing in Ehcache 2.0 with Terracotta. Terracotta always runs in fully coherent mode. It's like prides itself on it, but there are some use cases, bulk loading, like overnight batch process where you're bulk loading a cache, or even reference data that's never going to change. There are some use cases where you actually don't really want the cost of coherence. I mean, to do coherence, you need write locks and read locks across the cluster. So there's lock acquisition and release going on, which is slowing things down. So we've got a coherent equals false setting available on a cache-by-cache basis in the Ehcache 2.0, and that's actually been perf tested, and it gives approximately a 10 times performance improvement over these numbers. So the way we see it is, you know, you're doing financial stuff, read-write, you know, you need coherence, you need strong coherence. We're also adding JTA in, so you might need coherence plus transactions, and then there's these other areas where you don't need it, don't turn it on, get the performance benefit. There's your read-write latency. The test source is actually available. It's called Ehcache Perf. You guys can download that, pick holes in it. It's constantly being worked on. It's available publicly. You just need to join the Terracotta community, which is free. It's like joining the JBoss community or any one of those. So just to, I suppose, to whiz through to the performance conclusions. You know, most apps that need to scale need something other than the database. You've got an 80 times read-only SQL, and this is for the distributed cache. The standalone caching is another order of 2 of magnitude again. You've got much lower latency, and you've got a 30 to 95% database load reduction. And this thing hasn't really even been tuned. We're taking an app that is just an example app written by Spring, and just doing similar things to it to what I showed. It's not an app that's been purposely tuned to exploit every last bit of performance out of Ehcache. Oh yeah, and there's your latency, 1.5 milliseconds versus 120. Couple of other things. I'm going to show you, we'll get to the end. I'll actually find out who's interested actually before I roll on with it, but I'm going to show you the Ehcache console that we're building. That console is for all versions of Ehcache, including like Ehcache standalone. Terracotta's got a dev console. They've had a dev console for years. The other thing that you can be doing while you're tuning Hibernate is you can actually be having visualization into your caches and looking at your cache hit ratios and so on, which should be matching up with what you're seeing in Show SQL and what you're seeing in app performance. So the dev console is available if you're running Ehcache with Terracotta server, which you can do open source. The EX is a supported product, but Ehcache with Terracotta is also open source, so you can use open source Ehcache and open source Terracotta and get this dev console and actually play with that. And you can put that in production. It's basically a commercial open source where the deal is if you want support, and indemnification, the other stuff, you pay for it. But this dev console is available, and there's an Ehcache tab in this console. Now, I'm now going to talk. Let me just check the time. Right, so I'm pretty much tracking okay. I'm now just going to tell you guys what's in 2.0. So 2.0 this Friday, we've got the Hibernate 3.3 Plus caching SPI. So I've pretty much talked about that at length. I'm really excited about that. Steve Ebersole and the guys over at Hibernate are really excited about it. That's going to be great to get out there. The other thing is, the other thing in there's a sort of a, I don't know if I'd call it a bug or a feature, but as a trade-off for the extra performance, Ehcache 1.6 through 1.7 consumed more memory. I won't go into the reasons why it was, but there was some extra memory consumption. We've now, in Ehcache 2, thanks to Chris Dennis over in London, we've actually removed that extra memory consumption, so you'll see exactly the same memory consumption used for caching in Ehcache 2.0 as you did with 1.5 and lower. So that's kind of nice. So there's some improvements and just general improvements and fixes in 2.0 as well. But anyway, these are all features. So the other one is JTA. So if you think about it, like if you can take Ehcache and you want to cluster it, and you say you can cluster it with a coherent backend, then what you might also want to do is actually deal with the whole thing through transactions and actually XA transactions, so that you have that higher, more abstract level notion across your cluster. And so to me, it seemed to be an obvious step that we should do. So we've actually done that in Ehcache 2.0. We've got JTA. I think Alex Snaps just about killed himself writing it. It's very, very complicated and difficult to do. We've had James House from Quartz and the whole team basically working on this, and we've got with JTA, that's in the ehcache.org documentation, and we've got a sample app that you can check out of the Forge, run up and actually test with JTA. The JTA supports most transaction managers. If there's a transaction manager that we don't directly, like automatically support, there's a factory you can configure to actually chuck your transaction manager in. We support, the common app servers. We support a good selection of open source ones, and as I say, the others are configurable. And those transactions will work with Spring, EJB, and manual transactions. It's JTA, right? It's JTA. Where JTA works, this works. What does it mean? The cache is an XA resource. It means that you make changes to, you open a transaction, you make changes to stuff, including the cache or multiple caches, in a distributed environment, so right across the whole cluster. That's not visible to readers until you call commit. So it's the real deal. It's very hard to do, and we're pretty happy to actually have that in. Now, two things. One is that to support it, you need a copy on read and a copy on write function in your core cache. Ehcache core doesn't have that right now. Terracotta did have it. So in this release, we've only got it for Terracotta. In the next release, so the project name for Ehcache 2 was Darwin. The next project, which is starting off in the next week or two, is called Esperance, which will probably run for 2 or 3 months. That the plan is to actually have standalone JTA as well, so you can start using this standalone. And also, the one thing that we don't have, just simply because we didn't have time to think about it, was JTA for Hibernate. So we now tick the box on clustering with Hibernate, but we didn't support JTA with Hibernate. You can still do it, but Hibernate itself uses these soft locks in there to do it. So that Chris Dennis over in the UK has actually already written that implementation, which will be in Esperance. So it's already done. So I'm pretty sure it's going to be in there because it's done, and it wasn't that hard. We just didn't have time to think about it. So that's the JTA story. So first release in Darwin, and a follow-up release which is standalone plus Hibernate in the next release. And so that'll complete our whole JTA story. Something about, before I move off JTA, it's interesting, if you look at eventual consistency and the NoSQL movement and a lot of strategies that are being pursued, a lot of those strategies go out of their way to avoid XA. A lot of people have actually given up on a lot of architects and tech companies have actually given up on ever getting XA to work. So I think, a few nods of heads, but I mean, this might seem like to be running, against the tide for us to be actually implementing JTA in the middle of all this. But if you think about it, Terracotta has spent 6 years working on nothing but the distributed, how do you distribute objects in a coherent way? How do you have essentially, a thread-safe distributed heap? That's the only thing they've worked on for 6 years. So you know what? Like, I think it is something that we can actually do, and do really well, and do in a way that not just works, but is actually performant, because it uses exactly the same mechanisms. It uses exactly the same mechanisms as what distributed locking required anyway. So I think it's something that was very easy for, well, it wasn't easy, but it was much easier for Terracotta to do this than it would be for lots of other people. And I mean, when I was Ehcache on my own, there was no way in hell I was ever going near JTA, because I had people ask me, no way. Right. Now the other thing, so database, right? So most apps are really read heavy, and so you stick all these caches in front of your database and you offload your database. But then you get really giant companies, and Terracotta has them as clients. Some of the largest corporations in the world, and they max their databases out writing transactions to them. The solution there is to, I suppose, go the NoSQL movement and just don't use a database. Or if you are using a database, there's a technique called write behind, where you write. So what you do is you write to the cache, and then later at a time that is better in some way, we'll come back to what better means, the write to the database actually happens. Now, complementary to write behind is write through, where it's the same pattern, where you write through the cache, you write to the cache, and then you implement your own class. We call it a cache. The interface is called cache writer. So you implement that, and then the cache will call you. We'll call that class that you've written and you've configured into Ehcache, and then it will write to the database. And there's a guy here that's interested in dealing with stuff other than databases. It doesn't have to be a database. It's any store that you want it to be. It's just an interface. You can write to anything. The same actually goes with Ehcache has got cache readers. You don't have to read from a database. You typically do, but you could read a write to a REST service or whatever. It can be anything. The only specific tie-in between Ehcache and databases is OpenJPA and Hibernate, which are distinct modules. Everything else is just general purpose. So we studied what was out there on write behind, and we think we've done a fairly good crack at this. We've actually changed over Examinator, which is the standard Terracotta sample app, to use write behind. In getting it working a few weeks ago, we actually went back and changed some things about cache writer. So we've actually eaten our own dog food. But generally, the concept behind write behind is that you can get performance improvements through either picking a time where you want to write. So you might have an end of day peak and you actually want to spread out. The other thing that you might want to do is you might want to batch. So you might want to open a transaction to the database and then put through all of your mutations and then commit. And that, for most databases, is more efficient. So you can do that as well. The cache writer, or the write behind config, we've got about, I think it's about 10 or 15 knobs. I actually basically thought, I should know what they are off the top of my head because I actually came up with them all, but basically there's a lot of different parameters that you need to be able to configure to actually make this work in a wide range of applications. So you can batch. The other thing you can do that we support is coalescing, where if you've got a key, let's say you've got a key and you get a batch, you can either configure for batch mode or not batch mode. If you configure for batch mode, then you'll get called once the batch is built up. We've got a knob for don't exceed so many seconds before you actually call it and so on. But it's your interface. We call you, right? But you can, but with coalescing, what we'll do is we'll say, okay, there's been 8 changes to this key. We'll actually roll them up into one change. And then you'll only get, your implementation will only get called with the change that has to be applied. If that doesn't work, just don't use that feature, just turn off that config. So, this is something I think would be really exciting for people to play with. This works, this is in Ehcache standalone. Now, you may not realize, well, just thinking about it, if you, from a transaction point of view, if you've got write behind, the commit stops at the cache. If the cache is an XA resource, the commit stops there. So your cache will be coherent. If you've got a clustered cache, it'll be coherent. You've then got a queue, a write behind queue, which then you are hoping is going to make its way to the database. If it doesn't make its way to the database, there's problems. Right now, Ehcache standalone has an in-memory write behind queue. So you can use it standalone, but if it doesn't make it to the database, you need to basically cover that somehow. If you're using it now, if you're using Ehcache, if you've got a critical production system, you're using Ehcache with Terracotta, the write behind queue is on the Terracotta cluster. And the write behind queue, the writers, the cache writers, will be executed right across the cluster. So it's distributed workload and also persistent HA queue. It seems to me a fair trade-off. Like Ehcache, the typical use case is in memory with disk store. If you want that higher, if you want the HA, then wire in Terracotta, and we've got the write behind queue done as HA. So that's a pretty exciting feature, I think, to add. The other one is bulk loading. Now, bulk loading only applies to Ehcache with Terracotta. Ehcache, as I said, it's measured in microseconds how fast the operations are. So Ehcache itself does not have, it's got cache loaders, and it's got load all methods and things, but it doesn't have any specific API for bypassing and doing fast loading because it's just fast, right? We've had customers test it out and it's way fast. It's just, they don't need anything faster. When you've got a distributed coherent cache and you've got lock overhead, right, and you're doing a zillion things, putting a zillion things in the cache, then there's a cost to that. So what we've done is as I said before, is we've got this incoherent mode where, think about the CAP theorem and the trade-offs that you might want to do. For bulk loading, what we do is you can actually dynamically, at program time, you can call set coherent faults on the cluster. You can actually put your loads in. It's 10 times faster. Then you're done. You can put coherent, you can set coherent true, and then you can actually call wait for coherent, which will block until the whole cluster has become coherent again. You can also, with that coherent, you can have a cache that is configured in Ehcache.xml to be run incoherent the whole time. So you get that permanent 10 times faster. So I think it's a really nice thing to add in. As I say, standalone doesn't need it, but the Ehcache plus Terracotta does. I call it CAP configurability. I've covered that. The other thing, which is Ehcache with Terracotta only, is Terracotta has always had cluster events, so notification when a node joins or leaves the cluster, and also notification if your Terracotta client, it's hard to call it a client, it's really an L1, a level 1 cache, gets disconnected from the Terracotta server. So Ehcache 2 actually implements that, and you can actually you can register a listener, or you can configure one in the Ehcache.xml, and then you can take action if you were ever to get disconnected. What we're planning to do in Esperance is take that further, so that if you get disconnected, you'll have a choice of what you do about it, like a CAP theorem trade-off. What are your trade-offs? Right now, Terracotta will block, and then there's a configurable timeout, and then you can configure how many times to reconnect and so on. But I think it's nice to actually add extra knobs so that people can actually make the best choice for their app. I mean, one choice you do right now is you could get the event. You could actually, Ehcache has got, you can dynamically disable Ehcache, so you could get the event and actually just turn the cache off. It doesn't remove what's in there. It just causes gets and puts to bypass the cache. So gets return null, puts are no ops, and then when it comes back, you could turn it back on. You'd have to deal with what's happened to coherence in the meantime. You could actually, if you got caches that were read-only, you could turn those off. The other thing you could do is you could actually, with this listener, you could then pass through to your app that Terracotta was offline, so your app could decide whether to shut down or do something different. It's just a sensible thing to have when you've got a distributed system, to have a notification mechanism that you've lost network or something. I mean, Terracotta, there's there's an active and a passive, and you can have multiple passives, so you can actually configure the thing for like extreme HA. But what happens if you lose the whole network between the two? I mean, stuff can happen. So you need an events mechanism. Management. Another thing, people have asked for this for years in Ehcache, was the ability to actually dynamically alter the config while the thing was running. That's actually now delivered. So you can actually do that via JMX. So that's available in Ehcache via JMX. The Terracotta Dev Console, the pictures I showed you before, you can also do that through a GUI. That's really handy. You know, let's say you're playing, you're actually tuning your app, tuning your Hibernate app, you've got show SQL, and then you're actually got, you know, okay, I've got no show SQL happening, or you're getting show SQL, why is that happening? You know, that shouldn't be happening because I've got cache turned on, but your cache isn't big enough. You can look at your dev console and you can say, cache is full, okay, and then you can actually, in the dev console, you can go in and actually change it and increase the size of your cache. So I think that's kind of cool. And then the other thing is we're working on this web app for monitoring Ehcache, which, as I say, is throw in, you know, like the MySQL deal, where if you ever buy MySQL support, you get the MySQL Enterprise Monitor. So we're now about an hour and 10 minutes in. So what we probably should do now is take questions, and then we do it two ways. I can give you like a 2-minute quick view of the console, and then we can take questions, and then we can go to the pub. If I take questions, we probably won't get to the console. So everybody happy to put up with me for 2 minutes and I'll do a quick demo of the console? I've actually been working on this the last 3 weeks. So what I'm going to do actually with this thing is put it up on EC2 so that you'll have, you can just go around and click on a live demo. And we've got this little monitor test bed that actually creates caches full of marsupials and actually mammals. They're mammals, I think. And so you've got something to look at. Right, now that is the console. So there we go. So you've got the 10 registered cache managers. Now you've got you can click through one of these. You get stats. There's your cache statistics. This is configured at the moment to actually refresh every 10 seconds. You've got extra settings to show extra stats. You've got configuration, shows what your cache configuration is. Now this is across a whole cluster, and the way this works is there's a little probe jar. It's a very small jar. It's Ehcache 1.5 or above that we're supporting with this. You chuck the probe in, and then it's like a 2-line config that you add to ehcache.xml that just wires up the probe, and then you just give the address of the server. Now the idea is that this monitor piece is run by ops. It's not anywhere near your production systems. It's only the probe, which is very lightweight. And yeah, this is run by ops, and the idea is it can be used by ops, it can be used by devs to figure out what's going on in production. The other thing we've got is cache contents, so you can actually do a search for keys. And then you can actually get some metadata about that. You can also remove the key. One thing that we are interested in, well, we're thinking about doing, we haven't committed to doing it right now, is actually adding a proper efficient search onto cache. There's a lot of people that actually want that, a proper search feature. This implementation just iterates through keys, and I'll probably put a cap on the maximum cache size that you can use this feature against. We've got cache efficiency, which is some charting. Now this is not completely done. In fact, that one's got no data in it. Oh yes, it does. All right, so there's cache efficiency. So this is a graph. Now what we're going to do is add history, probably about a week's worth of history. We're just going to keep it in memory in the first release, but you'll be able to actually see before and after differences between doing code releases is the idea. Memory use is another one. We've actually been working on, rather than actual hard memory use, we've actually been working on estimating the amount of memory that your cache is using. We think we're going to get it pretty accurate so that you can, you get the dreaded out of memory exception when you're using Ehcache. By the way, if you're using Ehcache with Terracotta, there's a mode where you can set all of your max elements in memory to 0, and Terracotta by default will start evicting once you get to 70% of MX memory. So you can avoid those out of memories that way. For using, the other way is well, it's actually been a hard problem to figure out how much memory your system's going to use, and obviously it requires quite a bit of trial and error. With this memory use, you'll be able to drill down and look at memory used by each cache manager and what's used by cache. Now it's estimated, but we think it'll be pretty accurate. We're going to we'll take 1 in n samples depending on how big the cache is, and so on a put we'll actually do there's a library on Google Code with a BSD license called sizeof. We're actually writing our own, but then we found this one. It looks pretty good because having studied the problem, we've then, and this doesn't require any specific management agent or anything. So it's basically like the old C sizeof, where you actually walk through the object graph and actually look at, count up all the references and count up all the longs and everything else and the chars and the arrays, and you actually work out exactly what that's using. So when I say estimate, we'll do an accurate measurement of an actual element, but we'll only be doing sampling. So we're using statistical sampling to actually estimate how much the cache is using. The other thing you've got is an API. So there's this is it's a HTTP GET-based API. I wouldn't call it REST. It's all GET-based, and you actually add parameters. But you can actually use this then to create your own integration with your own ops console tools. It's kind of cool. And I've got it here, so you can actually just, you can interact with it. You've got ones that might require arguments, like this one. It'll tell you that it needs an argument, and then you can, name equals, that doesn't exist. But so you can play with it. So that's pretty much it. It's a work in progress, and there's a first look. All right, so I'll open up the floor to questions. I would like Ari Zilka to come up and help me field these questions at this point. Sure. So there was a question about JMX. Is JMX only available with Terracotta, or is it available with the Ehcache standalone? Also, is it available for distributed caching? So JMX got added to Ehcache about 3 years ago. So JMX is actually just in Ehcache, and the ability to actually dynamically reconfigure is in Ehcache. The Terracotta Dev Console uses JMX. It uses static values. There's also some sampling values where every 10 seconds, what's changed in that 10 seconds is taken, and so there's new JMX for that. So that's just all available as JMX. Are there other metrics that you look at other than cache efficiency when you're tuning? So the answer is yes, and also I'll define cache efficiency because I've discovered that not everybody has the same meaning for cache efficiency. Cache efficiency, I define in my docs, and I think it's a common usage, is cache hits to total hits. That's what I call cache efficiency. There's others, because you've got an L1, L2 architecture, and even with Ehcache standalone, you've got the L1 is in memory and the L2 is disk. So you've got a difference in performance, as you saw on those numbers, but you've got a difference in performance between the two. You've also got this coherent mode versus incoherent mode. So I look at cache hits. I look at how many. I'll also look at whether the cache is full. So, and also look at TTL. So I've studied quite a few real life performance, like big performance problems, and generally my starting point, which always frustrates the hell out of whoever's waiting for the answer, is to study the distribution. I just sit down. I'm actually a trained accountant by background. I did commerce, so I did a whole year of statistics, and so I always just sit down and actually graph the distribution. Actually, if it's not available, first thing I do is turn it on, and I actually get the distribution. And everyone's heard of the long tail. or the Pareto distribution. You hear about it because it's real. A lot of the e-commerce systems, the types of commercial systems that we build, exhibit that phenomena. And so what I do is I do a distribution, and some things do, some things don't. I mean, things like reference data, even if it may follow Pareto distribution, if you've got small data sets, you generally just want to cache all of those things. So I generally go through and make sure that all reference data is completely cached. And I'll tell you something that can happen, and I've seen this a lot, is there's 300 countries in the world. So you set your cache size to 300, and then the UN goes on and creates another country like East Timor, or a few others, and boom, or Czechoslovakia breaks down, or zip codes go up, or whatever. And what you find, I've seen this many times, is that you had a system that was working beautifully, and then suddenly the data set is one or two entries larger than the cache size, and the performance goes to hell. So you look at that, you look at your cache sizes, but you've got to. There's really no. I don't think there's any super quick answer. I study the problem, I study the data, I study the distributions, and I sit down with ShowSQL, and I sit down with places where I've worked. We've built our own tools akin to what we're building with the console, not as sophisticated as the console or the Terracotta Dev Console, but you look at those tools as well. You must see what your key statistics are, and not just in the last 5 minutes. You need to look at, that's why we're doing graphs. The other thing you'll find is that over a 24-hour period, the graphs will have a curve, and you'll start to associate where you've got perf problems. It might be at your busiest time, it might be at close of day, and you can see what is happening. When you're having a problem, you can look at what your ratios are. So like at these .coms that I've worked at, we had amazingly complete graphing of all these key metrics. It's more than cache efficiency, but that's the main one. The other one to watch is GCs. The other really, really big problem is GCs. A lot of people don't even know they've got garbage collection. I sat down to a system 4 years ago, and I walked in and I was like, this thing is really slow. And then they were testing it. It was like fast, fast, fast. So once again, I just studied it, and I just wrote a wget script, and I just hit the thing in production, for an hour, and then came back and graphed it. And like, as soon as you did that, your eyes visually, your brain visually can process data like nothing else. And I was like, ooh, what's that? And there was all these. It's amazing that there's so many developers that are crap at perf tuning. Had all these theories about what it was, and I'm like, okay, let's generate a theory. I do the Continuum falsificationism. I'm happy to generate as many wild ass theories as there are, but then I want to go in and falsify each one. So then I'll come up with an empirical test to do that. And so that was GC, and so with systems like What If, they run now with GCs, full GCs of less than 100 milliseconds, and that's graphed day in, day out, year in, year out, and that you've got to keep a very close eye on GC. GC with caches is a big problem, because it's one of the biggest problems that large heaps have, and one of the main reasons why you run large heaps is to do caching. The problems are not insoluble. I've got on my blog and also on the ehcache.org site, I've got some recommended settings, but obviously it varies widely depending on what your app's doing. But yeah, one of the things that you can do is actually turn on verbose GC logging. I generally recommend that, and that's the reason why in the Ehcache console we're going to be capturing the GCs and actually showing those on the graphs for you, because I think it's a common problem. Further questions we're happy to take at the Mars bar across the road.